Hi, good morning and welcome to today's class. In today's class, we'll be looking at number-based system. We said number-based system can be said to be the process of counting numbers in groups. Before we move further into today's topic, I'd like us to look at some of the objectives of this class. That at the end of the class, the students ought to have learned 1. How to convert numbers in base 10 to other bases. 2. Convert numbers in other bases to base 10. 3. Convert decimal fractions in other bases to base 10. 4. Carry out operations involving addition, subtraction, multiplication, and division of numbers in different number bases. 5. We also learn how to solve equations involving number-based system. And 6. The application of to apply the processes of the number-based system in computer programming. The process of counting in groups can be termed as number-based system. And we said the process of counting in groups of twos, the process of counting in groups of twos can be said to be the binary number system. Binary number system. And we say the binary number system has just 2 digits, which are zeros and ones. So in the binary number system, you have zeros and ones, and it is also said to be the base 2 number system. Also, we have the base 3 number system, which I will just type base 3 number system. The base 3 number system is made up of 3 digits, which are zeros, ones, and twos. So, a base 3 number system is made up of just these 3 digits. Also, we have the base 4 number system, which is also made up of 4 digits, which are, you can only find zeros, ones, 2, and 3s in a base 4 number system. We also have the base 5 number system. We have the base 5 number system, and in the base 5 number system, it's made up of digits 0, 1, 2, 3, and 4. Also, in the base 6 number system, we have digits 0, 1, 2, 3, 4, and 5. Also, in the base 7 number system, we have it to comprise of digits 0, 1, 2, 3, 4, 5, and 6, and so on and so forth. But let's look at the main number-based systems that we talk about. We have the base 2, we have, which is made up of zeros and ones. We have also the base 8, which is made up of zeros, ones, 2, 3, 4, 5, 6, and 7. The base 8 system is also referred to as the octal base system. We also have the base 10. The base 10 system, which is the base system used by we humans and is made up of 10 digits, which are 0s, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And it's also said to be the decimal base system. Okay, we also have in focus the base 16 number base system, and the base 16 system can be said to be alphanumerical, meaning it is made up of both letters and numbers, while we have digits 0 to 9 to take care of the first 10 digits in the base 16. We also have in continuation, we have A, B, C, D, E, and F to make up the other 6 digits. So in a base 16 system, these are the digits you can find, and we said it is also known as the hexadecimal number base system. Having known the different kinds of number-based systems that we have, it is also good that we know how each of these operates. Like the base 2 system is mostly used by our computer devices, because most of our circuits in the computers are most of them are made up of circuits. Most of the circuits in our systems have just 2 operations, which is the on and the off system. So in electronics, 0 is represented as the off state of the device, while 1 can be represented, is used to represent the on state of the device. So the base 2 system is mostly used by our electronics and by our electronics gadgets at home. Other base systems are also used by other systems, but the one mainly used by we humans is the base 10, which I also call the decimal base system. This is the one understood by man, and in order for us to communicate very well with our electronics, we need to know how they see whatever instruction that is being given. So that will lead us into conversion from base 10 to other base systems. So we need to know how this conversion is being done. So let's look at conversion of numbers in base 10 to other bases. This is the method applied in one serves for all. Now we have example 1, which says we should convert 25 base 10 to a number in base 6. In order for us to convert 25 in base 10, which is the decimal system, to a number in base 6, we need to use the long division method by dividing 25 and its multiple repeatedly by 6. So, using the long division method, I'm going to keep dividing 25 by the base I'm to convert it to, which is base 6. You keep dividing 25 and the multiples you will get by 6, and the remainder is written on the right hand side. And it goes this way. 6 into 25 is said to be 4 remainder 1. Let me use add to represent remainder. I will also divide 4 by 6, and 4 divided by 6, it cannot, so I'm going to write 0 remainder 4. This is how you keep dividing until you get to 0. And what is the equivalent of 25 base 10 in base 6 is said to be the remainders written from the bottom to the top. So we'll have it at 25 base 10, we'll say is equivalent to 4 base 6. That is 4 groups of 6 squares and 1 multiple of 6.